In this video, I'm going to show you some of the properties of polygons and also some ways that we can classify polygons. In this image, you can see some examples of shapes that are polygons versus shapes that are not polygons. And I encourage you to pause the video for a moment and see if you can come up with your own explanation for how these shapes are sorted. My strategy when I'm presented with a question like this of comparing one thing to another is to just start listing the properties that I see of each item that I'm comparing. So on the left hand side, the shapes that are polygons, I'm just going to start listing things that I see that are characteristics of polygons. And then I'm going to do the same thing on the right hand side. So one thing that jumps out to me on the left hand side is every one of these shapes has straight sides. The edges are straight lines. Sometimes they are curved in, like on this shape right here, but they're still straight lines. Whereas on this side, there are some straight lines, but not every single shape has that. So I'm going to write on the left-hand side, straight lines. On the right-hand side, the shapes that are not polygons, the thing that jumps out to me is I see several shapes with curves in them. So in this circle, there's definitely curves. In this oval, there's curves. There's curves right here in this shape. There's curves right here. So on the right-hand side, I'm going to write curves. Also on the right-hand side, I see some shapes that have intersecting lines. So for example, right here, this line right here intersects with this line. And in this shape, we have an intersection right here with this line right here. Now on the left-hand side, we do have some intersections. So for example, the side of this triangle intersects with this side of this triangle at this vertex right here, but we don't have any lines that cross when they intersect, whereas right here we have an intersection, but this line crosses with this one right here. Same thing with this line. We have an intersection in the middle and it crosses and keeps going. On the left-hand side, every time there's an intersection, it forms a vertex. So I'm going to write down on the right-hand side, we have intersecting sides that cross. In the non-polygons, another shape that stands out is this one right here, because this is actually just an angle. It only has two sides. We call this an open figure because it does not have a closed off defined area. And in this, the analogy that I like to use when I'm describing open figures is that if you think of this figure as a fence and you put your dog inside your fence, your dog is going to be able to escape. Whereas in this figure right here, that's a closed figure, if this is the fence going around it, if you put your dog in here, there's no way it's going to be able to escape. So we have an open figure right here. We have another open figure over here because, again, if this is a fence, the dog's going to be able to get out. And we have another open figure right here. Again, if this is a fence, your dog's going to be able to get out. So on the right-hand side, I'm going to write open figures. And in the polygons, I can also put closed figures because all of these shapes are closed. Now there are quite a few other properties of polygons on the left-hand side that I see. So for example, in this shape right here, I see opposite sides that are parallel. And I see the same thing in this shape, opposite sides parallel. And the same thing over here, opposite sides parallel. But not every one of these shapes has opposite sides parallel. As a matter of fact, in this triangle, there are no sides that are parallel. So that must not be a requirement for polygons. It's just something that polygons can have. I also see right angles in polygons. So there's one right here, right here. Of course, the square has right angles. This one has a right angle right there. I don't know, actually, that may be slightly smaller than a right angle. It's hard to tell without actually measuring that. So we call these, where the right angles are formed, we call these perpendicular lines. So this line right here is perpendicular to this line. It's also perpendicular to this line. But not every one of these shapes has right angles or perpendicular sides. So, for example, this trapezoid right here, there are no right angles or no perpendicular sides in it. So again, it appears that perpendicular sides is not a defining characteristic for polygons. And lastly, I see some shapes that appear that they have what looks kind of like caved in sides. So for example, this shape right here, it almost looks like that the side originally started right here and then somebody pushed it in and caved it in. And the same thing is true of this shape right here. It looks to me like this shape originally used to be this shape, and somebody has pushed in this side, and then the same thing on the top to create a caved-in shape. But not every one of those polygons has that characteristic. So again, it's probably something that it can be a characteristic of a polygon, but it doesn't have to be. So now that we've looked at some examples of polygons and non-polygons, let's try to put some of our observations into a definition for polygons. So first of all, this word polygons has a prefix poly that means many, and then a suffix gons, gons, which means sides. So that is a characteristic of polygons, that they have many sides. Matter of fact, we saw from our example pictures that they have to have more than two sides, because the example with two sides was just an angle that was not a closed figure. So I'm going to put at least three sides. And one of the other features about those sides that we saw that all polygons have is that they have straight sides. I'll put in parentheses, no curves. We saw that some of the non-polygons had intersecting sides that crossed, and none of the polygons did. So I'm going to put on here, no intersecting sides that cross. And then lastly, we said that all of our polygons were closed figures. So these are the defining characteristics for polygons. They have to have at least three sides. Those sides all have to be straight sides with no curves. They can't have sides that intersect and actually cross over. When they intersect, they just form vertices. And they have to be closed figures. Polygons are all named based on the number of sides that they have. And this picture shows you the common names that we use for polygons with various different sizes. There actually are some names for polygons with more sides than this, but these are the most common ones that you'll see. So we have a triangle, a square, you probably heard of a pentagon and a hexagon. Then you get into some ones that you haven't necessarily heard of. And this 9-sided one, often you'll hear that called a nonagon. So that's just another name for it. And this one, the 11-sided side, sometimes you'll hear that called an undecagon. In each one of these, the prefixes are what is going to give you the number of sides that the polygon has. So penta means 5, hexa means 6, hepta means 7, octa means 8, nona means 9, deca means 10, undeca means 11, and dodeca means 12. The only kind of oddball one is the square, because there's no prefix there. In triangle, tri does mean 3. Another way that we can classify polygons is to call them concave polygons or convex polygons. So I've got another figure that shows you some concave polygons and then some convex polygons. So you might take a moment and pause the video to look at this picture and see if you can come up with your own explanation for how these are sorted. So this goes back to one of the observations I made of our polygons originally, that on the left-hand side we see figures that appear that they've been poked in or caved in. So every one of these figures here has a caved in, at least one caved in side, whereas all the convex ones, there are no caved in sides. So I'm going to write down caved in, and I'm going to put that in quotes, caved in sides. However, if I want to put that more mathematically, what that means when I say a caved in side is it creates a reflex angle on the inside of the polygon. So if you look at every one of these concave polygons, they have at least one reflex angle, and this one right here has multiple ones. I'm not going to label all of them, but you can see that they have at least one reflex angle, whereas on the convex polygons, they're all just acute, obtuse, or right angles. So we could put on the left-hand side reflex angles and no reflex angles for convex. So again, every polygon can be classified as either concave or convex. It either has a caved inside, which creates a reflex angle, or it does not have any caved inside, which means it has no reflex angles in it. So here's another way that we can classify polygons. We can classify them as regular or irregular. So again, just like before, if you want to pause the video and come up with your own explanation for how we define regular versus irregular, this would be a good time to do that. It's a little bit hard to tell from this image, but if you look really carefully at all of the regular polygons, they all have equal side lengths. So one of the characteristics of regular polygons is they have equal sides. And if we actually pulled out our protractor, we could find that they also have equal angles. So to put that mathematically, we could translate this and say that they have congruent sides and angles. That means all of their sides and all of their angles are the same measure. And if you look at the irregular polygons, so for example right here, we have a longer side than we have right here. So this is a scaling triangle. For this to be a regular triangle, it would have to be equilateral, meaning all the sides would be the same and all of the angles right here are the same as well. If we look at this irregular quadrilateral, we have unequal sides and we have an obtuse angle right here, but an acute angle right here. And in this hexagon over here, it does have 1, 2, 3, 4, 5, 6 sides. So it is a hexagon, but it's a concave hexagon. It's clearly caved in on one side right here. The same thing with this octagon. It's caved in over here. So we know it has a couple of reflex angles, but then it also has an obtuse angle, and it even has, I don't know if that's a right angle or if it's acute without measuring it. It looks kind of like a right angle, but this is definitely an acute angle. You should also notice that all of the regular polygons are convex, and that's a must for them because if they were concave, they would have at least one caved inside that forms a reflex angle, and then will have other angles that are not reflex angles, which means their angles are not congruent, which is a requirement for regular polygons. So now that we've looked at some characteristics of polygons and looked at some ways that we can classify these polygons, I've got a screen full of various different shapes right here. And what I encourage you to do is pause the video for a moment and see if you can name every single one of these shapes in the most specific way that you possibly can. Some of these are polygons, some of these are not polygons, some of these are regular, some of them are irregular, some of them are concave, and some of them are convex. See if you can come up with the most specific name possible. And here are the names of each of these shapes. Take a moment and pause the video so that you can examine why each of these shapes has these names.